Okay, this is exam 2 for physics 101. First question, consider this figure. What is the normal force acting on the block? Well, first I just want to draw what are my force vectors. So I have my normal force acting up and my weight acting down. Draw my coordinate systems look like this. This angle is 90 minus 30, that's 60 degrees. And my normal force is going then to equal the y component of the force weight, that's this component, which is Fw sine of 60. Since the acceleration in the y direction is 0, I can say the sum of the forces in the y is Fn minus Fw sine 60 is equal to 0, so Fn equals Fw sine 60, which is the mass 10 times 9.8. I get 85 newtons, 85. So that's C. In the figure, what is the coefficient of static friction between the block and the inclined plane required to keep the block in place? So here we have a static frictional force, Fs, and it's going to be equal to the x component of Fw, that's Fw cosine of 60. So Fs minus Fw cosine of 60. By the way, this is the sum of the forces in the x direction. This is equal to max, which is equal to 0. So Fs equals Fw cosine 60. That's 10 times 9.8, or 98 newtons, times cosine of 60. It's 49 newtons. Alright, I already know my normal force. This is my Fs. Fs is mu times Fn. So mu is Fs over Fn, which is 49 over 85. Which is 0.57, 0.6. That's A. Which of the following statements best describes Aristotle's view of the natural world? Objects will continue in motion unless an outside force acts on them. No, that's Newton's first law. All objects are propelled by a mystical force that emanates from the earth. No. The mass of an object is a measure of its inertia. No, that's from Newton's first law. And all objects have a natural state which is at rest. The answer is D. Which of these make up the basic SI units for the Newton? F equals ma. That's kilogram meters per second squared. Looks like that is C for number 4. A force causes this bucket to accelerate upwards as shown. What is the magnitude of the force? Alright, well, sum of the forces equals ma. The sum of the forces is F minus Fw, because I also have the weight of the object, and that's equal to ma. So F equals Fw plus ma. That's 10 times 9.8 plus 10 times the acceleration, which is positive 5. 98 plus 50, which is 150 newtons. The answer for number 5 is D. From rest, we step on the gas for a Subaru, providing a force F for 4 seconds, traveling a distance of 10 meters. If the applied force were only half F, how far does the car travel in the same amount of time? Well, with half F, that means that we're going to get half our original acceleration. And we know that x is equal to 1/2 at squared. If I have half the acceleration in the same amount of time, I'm going to travel half the original distance. The original distance was 10 meters, so that means it's 5 meters, so number 6 is E. A block of mass m rests on the floor of an elevator that is accelerating upward. What is the relationship between the force due to gravity and the normal force? If it's going upward, the normal force is greater than the weight. It looks like it's A. Fn is greater than the weight of the object, or the gravitational force. This figure shows a block supported by 2 ropes. What is the tension in the rope on the right? There's my coordinate system. I have a force tension going in either direction. This angle on both sides is 50 degrees. And then I also have the weight of the object. If I just look at the forces in the y direction, I have 2t sine of 50. Alright, that's the combination of the 2 forces, alright, because they're equal. And then I have the force weight. It's not moving in the y direction, so I can say the sum of the forces in the y is 2t sine of 50 minus Fw equals 0, so 2t sine of 50 equals Fw, solve this for t, that's mg over 2 sine of 50. M is 23 times 9.8, which is g, divided by 2, divided by sine of 50. See, I get 150 newtons. Number 8 is C. Which of these is a conservative force? All field forces are conservative. The gravitational force is conservative. Frictional is not conservative, specifically, and the electric force is conservative. The normal force is not conservative because it is a contact force. The only truly conservative forces are field forces. So that's 1 and 3 for number C. 1 and 3. Which is usually larger, kinetic or static friction? Usually, almost always, static friction is bigger than kinetic friction, so that's B. In this figure, all the blocks have a displacement to the right. The magnitude of the force is the same for each block. Which force is doing the least amount of work? Alright, the least amount of work is the one, this force is doing no work. So that is A. Remember, work is equal to FD cosine theta. Here, my angle between my force and my displacement is 90 degrees, and the cosine of 90 is 0. This figure, two forces acting on a block. The block travels 3 meters to the right. What is the net work done on the block by both forces? So I want to know the net work. The work done by this force is FD cosine theta. That's going to be 4.2 times the displacement, which is 3.4, times the cosine of 30 degrees. I get 12.4. 12.37 actually. Now the work done over here is going to be negative because the cosine of the angle, cosine of 180 degrees, is -1. Or you can also just realize that the force is opposite the direction of the displacement. Gives you a negative work. Friction generally takes away from your energy. So it's equal to the force, which in this case is my kinetic frictional force, times my displacement, which is -1.1 times 3.4. And that's 3.74. Now, combining those two gives me 12.4 minus 3.74 gives me A, 8.6 joules. So for number 12, the answer is A. You throw a ball up in the air and it goes to a height of 16 meters. What is the speed of the ball when it's at a position of 8 meters? Alright, so the energy of the ball at the top is just mgh. It's all potential energy. And then at a height of 8 meters, it's going to be potential and kinetic. It's going to be mg times 8 meters plus 1/2 mv squared. The masses all cancel. We don't need that. And now I just solve for v. So I have g times 16, that's this term, minus g times 8, that's this term, divided by 1/2, square root of both sides, that's equal to v. So I have 8g, 2 times 8 times g, which is 16g. I get 12.5 or 13 meters per second. So that's A for number 13. You kick a ball whose mass is 1.3 kilogram at an angle of 43 degrees. You give it an initial velocity of 12 meters per second. What is the ball's maximum height? You can work this through our normal projectile motion. Alright, we just want to know what is the height up at this point. So you can work it using your equations of kinematics, but it's a lot easier if you instead use the energy. So I know that at the bottom, oh, and then the hint is consider the y component of the ball's initial velocity. The y component of the initial velocity, Vy, is equal to V0 times the sine of the angle, which in this case is 43 degrees. So that is 12 sine of 43, which gives me 8.2 meters per second. It's that energy in the kinetic sense that gives us our height. So all the energy that's due to that speed is going to go into potential energy. So we say 1/2 mvy squared is equal to mgh. And then I solve for h. So h is equal to vy squared over 2g. That is 8.2 squared divided by 2 and divided by 9.8. I get 3.4 meters. That's A. Number 14 is A. A car travels a distance x at acceleration a and does work w. If the car travels a distance 2x at the same acceleration, what is the work it has done? Well, work is equal to force times displacement. The acceleration remains constant, so that means the force remains constant, but the displacement doubles. That means you do twice the work, which is B. Which requires more energy? Take a car from 0 to 30 or 30 to 60. Remember, if we plot energy versus speed, it's a quadratic equation, so it looks like that. So going from 0 to 30 takes this amount of energy, but going from 30 to 60 takes this amount of energy, a lot more energy. So 30 to 60. It's number 16 is B. Consider this figure. 3 blocks of mass m slide down different inclined planes, each beginning at a height h. The coefficient of kinetic friction for the inclined planes is 0.3. Which block has the most energy at the bottom? Because we have friction, and friction is not a conservative force, then we have energy that's being lost on the longer path. So the block with the shortest path will have the most energy because it lost the least amount of energy to friction. So the answer is A for number 17. Number 18, you compress a mass on a spring as in this figure and release it. At what position does the mass have its largest speed? Alright, well, at its maximums, at x equal negative a and x equal positive a, the speed is equal to 0. All of the energy is in elastic potential energy, so the speed is 0. It's in the middle when your elastic potential energy is 0 that all of your energy is in kinetic energy. So the answer is B, x equals 0. A force of 1 Newton pushes a block over a rough flat surface at a speed of 2 meters per second. The force pushes the block a total distance of 8 meters. What is the power used to produce this motion? Well, power is equal to work over time, which is force times distance over time. Let's see, the force is 1 Newton. The distance is 8 meters. The time, well, it travels 8 meters at 2 meters per second, so it's going to require 4 seconds to do that. So this gives me 2 watts. Another way to do this, if you recall from the homework, I can find my power is equal to the force times the velocity. That's 1 Newton times my speed, which is 2 meters per second. That's going to be 2 watts. So the answer is 2 watts, C. Car is traveling at 22 meters per second, crashes into a wall. The collision occurs in 0.1 seconds, and the car rebounds at 2 meters per second. The mass of the car is 1,000 kilograms. What force is exerted on the car in this collision? My force is delta P over delta T. That is mv final minus v initial. That's my change in momentum over delta T. So I have 1,000 times my v final is 22 minus negative 2 all over 0.1. That's 240,000 newtons. 240,000. That looks like it's C. Number 20 is C. Be careful with your signs here. Make sure that you get your negative 2 for the rebound. Alright, the following figure shows a perfectly elastic collision where the two particles stick together after colliding. What is the speed of the particles? We have to consider that the initial momentum equals the final momentum. Alright, so I can just determine the initial momentum of these balls individually. This is going to be 2.2 times 3.2. That gives me 7.04. And the momentum of this is negative 1.2 times 4.1, which is 4.92. So the negative 4.92. So the total momentum of these two is 2.12 kilogram meters per second. That's the total momentum. That is 7.04 minus 4.92 is 2.12. So this is my initial momentum. It's also my final momentum. So I can say that 2.12 kilogram meters per second is equal to m1 plus m2, because the masses are stuck together, times Vf. So Vf then is 2.12 divided by 2.2 plus 4.1. This gives me 0.34. That's C. So for number 21 is C. Which of these statements is most appropriate for an elastic collision? In an elastic collision, like for example the collision between gas particles, both energy and momentum are conserved. So that is C. A uranium nucleus at rest undergoes fission and splits into two fragments, one heavy and the other light. Which fragment has the greater speed? Well, they both have the same momentum, right? So since one has a smaller mass, it has the greatest speed. So that is B, the light fragment, has the greater speed. Collection of particles has a total momentum of 0. Which of these statements is true? The kinetic energy of the particles must be 0. The particles have no mass. The kinetic energy of the particles might be 0, but not necessarily. Or the particles are definitely moving. Well, if it has a total momentum of 0, it could mean that the particles are not moving, but not necessarily, because since momentum is a vector quantity, if you have particles moving in opposite directions with equal speeds, then they're going to have the same they're going to have 0 momentum. So that would be B, that the kinetic energy might be 0 but not necessarily. And this is A. There are the answers for these.